Good morning, my YouTube viewers. Crystal here. I'm here this morning because I wanted to give you some data science information that I produced myself. It's to do with United States presidential elections 2020. I'm going to be making a blog post on this as well, but I wanted to make a video for people who don't read blog posts. The title of the blog post is going to be something like, what candidate did Random Forest predict would win the 2020 presidential elections? And basically what I did, so this is not a competition question, so fortunately you don't have to listen to me recite the competition question for you. It's just the question that I'm asking is, what candidate did Random Forest predict would win the 2020 presidential elections? That's the question for this video. So the first thing I did was I imported the libraries that I would need. I imported Pandas, NumPy, Matplotlib, and Seaborn. The next thing I did was I imported the CSV files that I would need, and I got the CSV files from the past elections. I got it from electionlab.mit.edu data, and the present elections I got it from Kaggle. And so I have a link to the websites where I got the CSV files. I loaded the CSV files on my GitHub account, so you're more than welcome to use the ones that I got from my GitHub account if you want to practice a little bit with the presidential elections. So the first file I called up was past, and you can see and so you can see that these are all the past election results from 1976 to 2016. The second CSV file that I called up was present, and that's the election results for 2020. And you can see that these are different types of CSV files. So that means I have to make the two CSV files similar, otherwise it won't work when I put it into the model. So for the present file, I created a new model called year, and I called that 2020. So now we have a year in there, and that's 2020. And for the present column, I renamed total votes to candidate votes. So that's a renaming of a column to make the column fit in line with the past CSV file. Now what I've done is I've made a pivot table, and I grouped by state, candidate, party, and year, and we counted it on candidate votes. And that was for the test file. So now you can see all the candidate votes in the test file. So that test file is actually going to be your test data frame. So now what we've done is we're going to create a train data frame, and we're going to use state, candidate, party, year, candidate votes. And so that's going to be very similar to the test file, because the train file and the test file have to be very similar, otherwise they won't fit into the model. Now what we're doing is we're checking for null values. So candidate had null values and party had null values in the train file, but not in the test file. So what I decided to do was I decided to define Democrat as a 1, Dem as a 1, Republican as a 2, and Rep as a 2. And so what I've done is I've made a dictionary, and I've mapped that dictionary into the train file and the test file. And now what I've done is whenever I map the dictionary into the train file and the test file, I had a lot of not numbers, a lot of null characters. So what I did was I replaced all of those null characters with 3. So basically we've got a situation where number 1 is Democrats, number 2 is Republicans, and number 3 is other. And so on the candidate, anywhere in the train file or the test file where the candidate comes up with a null vote, I just replace that with blank votes. So now we've got the party has been replaced with 1, 2, or 3, which is a numeric value, and candidate has been replaced with blank vote whenever it doesn't turn up. So now we've got the train file that the data has been cleaned up. And you can see the party is numeric because that is what the model wants to see. In any place that was not a number in the candidate, it's been replaced with blank vote. And we have the same thing with the test file. So anything that's other is going to be a number 2, number 3, Republican's going to be a number 2, and Democrat is going to be a 1. So now what we're going to do again, we're going to check for any null values again just to see if we've left anything out. And no, there's no more null values in the train file or the test file. So now we're going to do a graphical representation. We're doing a graphical representation of the party. So number 1 and number 2, where Democrats and Republicans are roughly even, but you got a lot of others. And in the test file, it's the same. You got number 1 and number 2, that's Democrats and Republicans, are roughly even, and then you've got others. But, the only thing that we're really interested in is the Democrats or the Republicans, because as far as I'm aware, we've never had an independent candidate win. As long as I've been alive, it's always been Democrat or Republican that's won the election, although people from other groups have run. Now what we do is we define our X, Y, and X test variables. So Y is train candidate votes. We also create a variable called candidate votes equals test candidate votes, because that's going to be used at the end of this program. And then X is train drop candidate votes, axis equals 1, and X test equals test drop candidate votes, axis equals 1. So we've got our Y variable declared, we've got our X variable, and we've got our X test variable. And you can see that these data frames are very similar, very similar. So now we've got X info because we want to see whether the columns are objects or floats. So we've got two columns that are categorical, and we've got 2 columns that are numeric. And so now what we're going to do is we're going to use our column transformer. So under the numeric features, we're going to put columns 2 and 3 in the numeric features. We're going to put it in a numeric transformer and a pipeline, and we're going to call it imputer, iterative, imputer, random state equals 1, and scalar equals standard scalar. Just put it in there as a matter of course. And then column 0 and 1 are going to be our categorical features. So we're going to have a categorical transformer, pipeline is steps, imputer, simple imputer, strategy equals constant, fill value equals missing. And then we're going to one-hot encode those columns. So, and it says handle unknown, ignore. And so there's only going to be like 3 one-hot encoded. It's going to be like, well, we don't know how many one-hot encoded it is, but it's one-hot encoded. And then we're going to set up our preprocessor is our column transformer. Our transformers equals numeric transformer, numeric features, and categorical transformer, categorical features. Now what we're going to do is we're going to split our X up for training and validation. So X train, X val, Y train, Y val equals train test split, X, Y, random state equals 1, test size equals 10%. And then we check the shape of these data frames that we've created. Now we create our pipeline, and we're going to use Ada Boost Regressor with Random Forest. And so you can see that here. And we're going to fit X train, Y train into the model, and we're going to print our score. It's 99.88%, which is pretty good accuracy. Now we're going to make our predictions on the validation set. So ypred equals model predict xval, ypred equals ypred.astype int, ypred equals 0 if I is less than 0, else I for I in ypred, and print the score. And so basically, if any of the values were less than 0, then they're automatically made 0. So we got a 95.50% accuracy on the validation set. And you can see this is the data frame if you want to check your actual values against the predicted values. The next thing we're going to do is we're going to predict on our X test, and we use the same formula for X test that we used for X val. And what we did is any of the votes that are less than 0 are automatically made 0 using that line of code. And we have a 91.62% accuracy on our X test, and we've made a data frame so you can check the actual values against the predicted values. And so what we've done now is we've added a column called prediction to our test data frame so you can compare the candidate votes against the predicted values. And then what we've done is we've just used a group by to plot a bar plot. And you can see that number 1, Democrats, and number 2, Republicans are roughly the same. And then there's lots of write-in votes elsewhere. So I've defined it as number 1 is Democrat, number 2 is Republican, and number 3 is other. And so this is the predicted winner. This is what Random Forest predicted. Random Forest predicted that the Democrats would have almost 63 million votes, and the Republicans would have almost 61 million votes, and other would have almost 3 million votes. But the actual values were the Democrats had almost 81 million votes. The Republicans had 74 million votes, and other had close to 3 million votes. So that's the problem, because you have about 18 million votes more than Random Forest predicted for the Democrats, and you have about 14 million votes more than Random Forest predicted for the Republicans. So that does indicate that the system was flooded with ballots, and that's what they're saying. They're saying that the system was flooded with ballots, and all of these ballots were voting for Joe Biden. And obviously I'm not there, and so I can't really comment on that, say whether it's true or not. I mean, I have my own personal opinions, and my personal opinion does think that there were some anomalies going on. But the only thing I can do is tell you what Random Forest predicted. Random Forest had an accuracy of almost 92%, 91.62%. And so that's a pretty good accuracy when you're dealing with machine learning. And so there were a lot more votes than what Random Forest predicted there should be. So that's definitely an anomaly that needs to be looked into. And it is being looked into today, 1 December 2020, the day that I'm making this video. So this comes to the end of our video. This is the first data science project that I've done on my own. Um, just myself, use my own initiative to do it. If you like my video, please like, subscribe, and share. If you like the work I do and want to support it, I've got my email address to my PayPal account down below. I don't have enough subscribers, so I have to ask for donations. And thank you so much for watching my video, and I look forward to making the next video for you and the next data science project for you.